Hi everyone, in this video I'm going to talk about smart contracts on Ethereum virtual machine. This is not going to be a detailed explanation of anything because I'm not an expert at this as of today, but I'm going to share what I've learned, and I'm a software developer, web application developer, so I'll try to compare how we do it today, like generally how everyone does it, and what a smart contract can can change, at least from what I understood. So we can start talking about smart contracts by giving a real world problem. So what we can talk about is, for example, there's an e-commerce website, and when a buyer clicks a buy button, and they give their credit card information, let's say, before sending this money to the seller, web application can put this money on an escrow account, so it will stay there, which everyone can see and audit if the money is there, not sent to seller after being confirmed that this package actually is received by the buyer, and the package is actually what it is. It's the same thing that it is advertised. So today, this is being done like big e-commerce website, let's say AWS, Amazon, eBay, PayPal. They are trusted because they're in this business for many years, but they don't do it for free. They have some fees, and so this is how it goes. But with smart contracts, what can be done is, actually, before jumping to that, if you are going to kind of do the same thing, hey, I have a web application, e-commerce web application, and this is how I'm going to, if you're trying to convince your potential users, I'm gonna put this money, what you send, in an escrow account, and it's not going to be sent to seller until you are happy with what you receive, without without a history of a trusted business, let's say. Probably it wouldn't be easy to convince people stop using PayPal, eBay, Amazon, and start using yours. But with smart contracts, because this you can define this escrow functionality into a piece of code, and you can share, and everyone in this in this ecosystem can audit and your code, so that they can start trusting your application in terms of escrow functionality on day one. So how it can be done? Before jumping to actually smart contracts, we should give a general definition of accounts in Ethereum virtual machine. So there are external accounts which are used and which are manipulated by the people, by the users. So there's a human being sending some ether from this account to that account, and it's so this is how they are being used, and they have address and they have balance. The other accounts are internal accounts, and these are called smart contracts. They have an address, they can have balance, and they have a piece of code. It can be written in Solidity, Viper, and in Ethereum 2, I think they will support Rust, C, if I'm not wrong. Anyway, I'm sure Rust, but I'm not quite sure about the other ones. So, so for this account, and human, like from this account, can send some ether to this account, but this account can only send some ether to another account, either internal or external, when some certain conditions are met. So sending money from this smart contract actually has to be dictated, has to be written in a code. So this is what smart contracts, and smart contracts are known as internal accounts as well. So these are some fundamental information required to be able to understand what actually Ethereum virtual machine is. Okay, so if this is the problem definition that we have, and let's talk a little bit more about smart contracts. So let's say you're a backend developer, you designed your smart contract, escrow functionality or whatever functionality it is, and you upload it to Ethereum blockchain. From that moment, as you already heard, as you already know, blockchain is immutable. So what that means is, when you upload it, this smart contract will have an address and the code will stay the same, and you cannot change it. So this can be an advantage or disadvantage. So we're going to talk about it. So from a developer perspective, and you might know every code has a bug. It's just a matter of time. Someone will, realize it. Someone will hit the trigger, and bug will, reveal itself. So that means you need to change the code. There are some ways. There are some workarounds on that, which we can talk in another video. But one straightforward, technique is writing a new contract and replacing your previous contract with the new one in your front-end application. The second kind of good thing is using smart contracts in Ethereum. There's no downtime, so it's zero downtime. What that means is, if you put your application, let's say the e-commerce application, a traditional way on AWS cloud services, let's say, and if you stop paying the bills, that means they're gonna shut down your EC2, and your server will go down, and you won't be able to serve your customers. Or if something happens, in data center, and your server goes down, so you're gonna, your users won't be able to use your application. But with Ethereum, I'm gonna just jump into last slide here. There are many nodes out there, and if one of them goes down, this one has this same blockchain, same information, same code, so your application will always up and running unless all nodes are goes down, which is not expected. So this is what zero downtime. No web server. Actually, we just told you about it. You don't need to run a web server for your application only. You're just going to upload it to blockchain, and it will be reachable from anywhere at any time. And this costs some money at Ether, in this scenario. So what that means is, when you upload a smart contract into blockchain, so you change the state of the Ethereum virtual machine, and every state change requires some gas, because let's jump into the next slide here, because to be able to improve, let's say, blockchain, add something new to the blockchain, it has to be verified to be able to keep the decentralized feature of blockchain technology. Miners has to do some work, and this requires some computational work, and they have to be compensated. So gas fees mostly goes to miners. So in another example, for state T plus 1, what that means is, to simplify it, let's say if you stop the time, literally, now, and right now, let's say Alice has 10 Ether in her account, and Bob has 2 Ether in his account, and Alice wants to send Bob 2 Ethers from her account. Next state, so after this transaction actually completed, Alice will have 8 and Bob will have 4 Ethers. So this is a state change. This is called state change, and every state change happens after a transaction being completed, and this requires a gas fee. So what that means is, when you interact with that application, when you take some actions, you have to pay for it. So we're going to talk about possible gas fees and everything in another video. Right. The other thing is, smart contracts are open, so there are Etherscan's web page, which we can check later. so you can see what a smart contract does, and before using it, you can make sure what's gonna happen when you click the button. The other thing is being reusable. So as we said here, in every node, blockchain is being replicated, and there are tools that you can introspect, or you can inspect what active blockchain has, whatever, or you just happen to come across a smart contract on, for example, GitHub, and you want to use it. All you need to do is just grab the address of it, like this here, and you can start using it. You don't need to ask for any permission to the owner, to the creator, whatever. As long as you're happy with the code, just take it and read the code, what it does, and start using your front-end application, which we're gonna talk just in a moment. Right, reusable token. Okay, we talked about gas fees and we talked about immutability. So I put it in green and red as well. So good things, bad things, because immutable can be a good thing and bad thing. Just depends where you look at it. Gas fees, we just talked about it. And let's talk about an implementation from start to end. Let's start from a backend perspective. So you wrote your smart contract and you want to implement it into your e-commerce application, let's say. What you need is you need to interact with the Ethereum network. To be able to do that, you need to talk to a node, right? Any node, doesn't matter. You can even use your own node. So what that means is any average laptop actually can be turned into an Ethereum node, and it's very simple, which we're gonna hopefully do it in another in another video. So you can use that node, and you're going to upload. To be able to upload, you need an account, like the external account, because you need to pay for this action, and to be able to pay, you need an account, because otherwise accounts are the way of keeping who has how much ethers. So let's say you uploaded your smart contract, it's in the blockchain. Now you need to use it. You need to enable your users to interact with this smart contract. For that, there are several libraries, right? JavaScript libraries, Web3, ethers, and we're gonna see an example in another video. And so this is going to be basically an HTML code using a JavaScript and a web form. So when you say I want to send some money to this address from that address and this amount, and when you say address, again we are talking about address like this and that. So these are Ethereum, and your library will know which blockchain you're trying to reach, and when you give an address, it will try to find this address and send some ether or receive ether, or actually basically it just initiates a transaction, right? So from your front end, and so you need to interact with the node when you upload your smart contract. But when this is finished, and when you upload your when you serve your front-end files, you don't you still need to communicate with a node, but it can be done by a provider, or you can do it again through your own node, and we will talk about that. You can use a regular web server, or you can use decentralized file sharing. One of them is Swarm, and what Swarm does is, or some other similar networks, actually they are not like a backend, but they are kind of decentralizing front end, right? When you upload your JavaScript code or HTML code, it will be reachable anytime to the users of this network, and we will talk about that later. So yes, now we can talk about the end user who is going to buy stuff, and they don't really, how can we say, they don't really care about how all this technology being implemented. They're just going to send some money and expect their product to to reach them, to be delivered them. For that, what they need is they need to share their Ethereum account like this to be able to send obviously some ethers, and for that they are going to use their regular browser, let's say Chrome, Opera, whatever. But what they need is a browser extension. A very well-known one is MetaMask. So you're giving your details, you're creating a wallet on MetaMask and importing or creating a new account on MetaMask, and interaction with the DApp applications, decentralized application, are going to be handled via MetaMask, and MetaMask will always tell you, hey, are you happy to continue? You're sending this amount of ether to that account, and this will cost this amount of gas or something like that. Alright guys, this is the end of the video. I hope you enjoyed. If you enjoyed, please like, and I'll try to add some more videos, especially when we get our hands dirty by writing some codes. Thank you.